Welcome back to Functions and Graphs Made Easy. This is the second video of this series, where inshallah we'll talk about domain and range. Now it's time to answer two very important questions. What values are allowed to go into a function, and what values can come out of a function? The answers are called the domain and the range. Once you understand these two ideas, reading graphs and studying more advanced functions becomes much easier. So, let's begin. Quick review. In the previous video, we learned that a function is a rule that assigns exactly one output to every input. The input is usually called x, the output is usually called f of x, and sometimes we use the symbol y instead. So, instead of writing f of x equals 2x plus 3, we could write y equals 2x plus 3. But here is something important. Not every number can always be used as an input. For example, if I ask you, can we divide by 0? You would probably say, of course not. That's actually an example of a restriction on the set of inputs, and we will see how that works in just a moment. So, what is the domain? Imagine a function as a machine. You put an input into the machine and the machine gives you exactly one output. The domain is simply all inputs that the function can accept. Look at this diagram. There is valid inputs and invalid inputs. Another way to say it is the domain is the set of all inputs values for which the function is defined. Let's look at a simple example. f of x equals 1 over x minus 4. Can we substitute x equals 5? Can we substitute x equals minus 10? Yes. What about x equals 4? No, because the denominator becomes 0 and division by 0 is impossible. In fact, every real number works except 4. So the domain is minus infinity for union for infinity. This notation simply means all the real numbers except 4. What is the range? Imagine trying every allowed input. Every output you obtain goes into one collection. This collection is called the range. Range equals all possible outputs. Example, f of x equals 2x plus 5. If x can be any real number, the output can also be any real number. So the range is also all real numbers. Notice that this is an example where the input and the output sets are the same. The codomain. The codomain is slightly different from the range. The codomain contains the range, but it may be larger than the range. Look at this diagram. So, not every element of the codomain has to be an image of an input. How do we find the codomain? Actually, the codomain is given to us in the definition of the function. In textbook, you might sometimes see a function defined like this. F from the domain to the codomain x gives f of x. For example, f from real numbers to real numbers from x to x plus 3. Notice how the shape of the arrow is different in the second line. And also notice that when we say from domain to codomain, it does not mean that every element of the codomain is an image of an input, like we showed in this diagram. Finding the domain from an equation. Now, let's learn how to find the domain. Most of the time, we simply ask, is there any value of x that makes the expression impossible? There is two common situations you should always check. Rule 1. Never divide by 0. Example 1. f of x equals 1 over x plus 3. Can we substitute x equals minus 3? No, because the denominator becomes 0. Division by 0 is undefined, so the domain is all real numbers except 3. This is how we read this notation. Example 2. g of x equals x plus 1 over x squared minus 9. The denominator is 0 when x squared minus 9 equals 0. Rearranging the equation, we get x squared equals 9, which means that x equals 3 or x equals minus 3. So those two numbers must be excluded. Therefore, the domain is all real numbers except minus 3 and 3. Rule 2. The expression inside a square root cannot be negative. But here is an important note. This rule is only true when the range is restricted to real numbers. But when the range goes beyond real numbers, this rule stops to be true. But what does that even mean? Is there is a set of numbers beyond real numbers? That is a story for another day. Here we just deal with real numbers. So, example 1. h of x equals square root of x minus 5. The expression inside the square root must be greater than or equal to 0. So, x minus 5 must be greater or equal to 0, which means x must be greater or equal to 5. Therefore, the domain is 5 infinity. We use a square bracket with 5, but when dealing with infinity, we always use a parenthesis. Example 2. k of x equals square root of 9 minus x. Now we solve 9 minus x greater than or equals to 0. So, x is smaller than or equals to 9. The domain is minus infinity 9. Finding the range. Finding the range is sometimes easy and sometimes a little harder. Let's begin with a simple example. Example 1. f of x equals x squared. Can the output ever be negative? No. The smallest output is 0. So the range is 0 infinity. Example 2. f of x equals x squared plus 4. How do you find the range in this example? Here is a simple way to do it. Write the function as y equals x squared plus 4. Then find x in terms of y. So we write x squared equals y minus 4. Therefore, x equals square root of y minus 4 or x equals minus square root of y minus 4. In either cases, y minus 4 must be greater than or equal to 0. So, y must be greater than or equal to 4. Therefore, the range is for infinity. Example 3. f of x equals minus x squared. So, rewriting it as y equals minus x squared. So, x squared equals minus y. Therefore, x equals square root of minus y or x equals minus square root of minus y, which means minus y is greater than or equal to 0. So, y must be smaller than or equal to 0. Therefore, the range is minus infinity 0. Summary. Whenever you are asked to find the domain, ask yourself, What inputs make this function impossible? Look for division by zero, square root of negative numbers, any other operation that is not defined. Whenever you are asked to find the range, ask yourself, what outputs can this function actually produce? Sometimes every real number works. Sometimes there are restrictions. Practice questions. Pause the video and try these on your own. Find the domain and range of f of x equals 5x minus 8. Find the domain and range of f of x equals 1 over x plus 9. Find the domain and range of f of x equals square root of x minus 6. Now, the answers. For question 1, the domain is all real numbers and the range is all real numbers. For question 2, the domain is all real numbers except minus 9 and the range is all real numbers except 0. For question 3, the domain is 6 infinity and the range is 0 infinity. Today we learned one of the most important ideas in mathematics. The domain tells us which inputs are allowed. The range tells us which outputs are possible. These ideas appear throughout algebra, calculus, and beyond, so make sure you're comfortable with them. In the next video, inshallah, we will learn how to find the domain and the range visually using graphs, which is a clever mathematical idea that connects algebra with geometry. So, stay tuned. If you found this lesson helpful, don't forget to like the video, subscribe, and download the free PDF of this lesson from the link in the description below, which contains practice questions, definitions, and more examples. Thanks for watching, and inshallah, I will see you in the next lesson.